Alrighty, welcome to the rest of the reproductive chapter. Here we're going to talk about both males and females. First, let's go ahead and start with sexual function in the autonomic nervous system. So for both males and females, it's a really complex set of reflexes, both including sympathetics and parasympathetics. Typically, sexual arousal will lead to parasympathetic outflow in the pelvic nerves, which seems a little counterintuitive, but remember parasympathetics rest and digest, so you're going to have a pool of blood in this area, which makes a lot of sense for erection. And then males specifically, so parasympathetics will get initiated or activated first. Blood flow will increase to the penile arteries. The increase of blood to this area will also be stimulated by a release of nitric oxide, NO gas. And nitric oxide is a potent vasodilator. So a lot of the smooth muscle in the arterial walls will relax, vessels will dilate, blood flow will increase to this area, and eventually the penis will engorge with blood, and this will actually what is forming the erection. It's actually really cool, the microanatomy in this area. There are these really interesting like capillary complexes that will slowly fill one at a time so that the penis can remain erect for as long of a period as possible. So if any of the blood does leave, it leaves in like segments, not just all at once. Anyway, okay. Secretion from the bulbourethral glands will lubricate the penis, and this is called pre-ejaculate. This will contain some sperm. Sympathetics will then get activated, or sympathetics that do get activated, will stimulate peristaltic contractions of the ampullae of the ductus deferens. So this is the most inferior portion of it in order to push things. This is the most superior portion of it to help pulsate through or make peristaltic contractions of all of the spermatids as they travel through the ductus deferens. Sperm will get pushed through the urethra. Seminal glands will contract to add their seminal mixture. And then finally, the urinary bladder and the internal urethral sphincter will contract to prevent any backflow of any of the semen into the bladder. And then you finally have the function of these sphincters contracting in order to prevent any backflow is called emission. Ejaculation is where you actually have the contraction of the supportive muscles that are surrounding the base of the penis. These are ischiocavernosus and bulbospongiosus. These are equivalent in females as well. The prostate will also contract to pinch off the urethra in order to promote an ejaculation. Everything basically wants to build up pressure in order to move semen as far away and up through the female reproductive tract as possible in order to get as close to the ovaries as possible. During an ejaculation or an orgasm, the temperature will increase in the male body, increase in heart rate and blood pressure as well. Then, immediately after an ejaculation, there will be what's called a resolution phase. Everything decreases, everything slows down, and then you finally go very quickly into a refractory period. And the refractory period involves no ability of another orgasm to happen until you're out of the refractory period, which is variable across males. Loss of an erection is, the vocab word is detumescence. No idea, I'm sorry. And then erectile dysfunction is the inability to achieve or maintain an erection. This can be due to a wide variety of reasons, or a combination of reasons, or it might be acute, it might be chronic, but some of the examples are listed here on this slide. For females, once parasympathetics get activated, you have engorgement of the erectile tissues. That includes the clitoris and vestibular bulbs. Remember, the clitoris isn't only just that external portion, it also has an internal portion, so that portion will also engorge with blood, and then that will also push on the anterior wall of the vagina as well. You have an increased amount of mucus secretions to help lubricate the area, assuming that a vaginal sex will happen. And then you have increased sensitivity to this area due to the increased amount of blood flow. And also the mucus secretions too, to help stimulate those free nerve endings. Parasympathetics also will involve contraction of the smooth muscles of the nipples to increase sensitivity. This is not consistent among all females, but is in some levels there. There will also be peristaltic contractions of the uterine and vaginal walls. So the vagina will also contract in a rhythmic fashion. The uterus will also contract. The thought is that once sperm enters this area, that it will help almost propel it towards the uterine tubes, which also contract. This is during vaginal intercourse. And again, you have contractions of bulbospongiosis and ischiocavernosus during the equivalent of this erection as well, or equivalent of an erection in men or males as is in females. These are supportive muscles of the labia majora and minora. Majora, sorry, not really minora. And then eventually you finally have an orgasm. There is no refractory period, which means that multiple orgasms can occur sequentially, variable on the amount of time it happens in between each. So I would practice this if I were you, but I am not a sex doctor. So anyway, and overall there's pretty much similar physiological events as a male. So increased heart rate, increased blood pressure, followed by a very quick decreased heart rate, decrease in blood pressure. All right, so what happens whenever egg actually meets sperm, right? What happens when the ovum actually meets that spermatozoa? Yeah, fertilization. And this video is going to show you what fertilization looks like. But before we talk about that, I want to highlight a couple of things. If you're interested in more about how fertilization works and the details of it, chapter 29-2 has a lot more info on it. We don't talk about it in this course, mainly because it's not required as one of the general transfer pieces for the community college system, but it is a really important concept for you to understand. So I would encourage you to look at it, but we will not test you over it. Okay, so only about 40% of zygotes actually survive their first trimester. So what does that mean? So after the ovum meets spermatozoa and they fertilize, that becomes a zygote. So only 40% of those zygotes will even survive the first trimester. Okay, lost pregnancies. So a miscarriage is defined as something that's lost before 20 weeks. A stillborn is defined as something that's lost after 20 weeks. Okay, and a typical pregnancy is 42 weeks, 9 months, or is it 40 weeks? 38 weeks? Did I say 4 months? Oh my God, 9 months. Okay. Over 50% of all conceptions, so all fertilizations, all zygotes, are spontaneously aborted without you even knowing. So there could be a fertilization, it could not implant. There could be a fertilization, it could implant, and then it could just be shed during menses anyway for whatever reason. But over 50%. So a vast majority of the time, you wouldn't even know it. And a larger percent of the time, and I'm sorry, and on top of that, let me add that at the very end, sorry. So, and then of confirmed pregnancies, between 15 and 20% actually end in a miscarriage anyway. So if you take all of this and you do some crazy stats, right? The percentage of being, like the percent chance of you being able to actually have a child is super small, right? Because you have to combine the 15 to 20% ending in miscarriage, 50% or greater than 50% of the time they fail anyway. And even if they do make it to being a zygote and being implanted, 40% of them don't make it, right? So it's such a small number. So it's amazing that we're even able to conceive in the first place. Okay, we are not going to test you on any of those numbers, but I think it's important as women to have some of these numbers to remind them, like this can be a really difficult thing if you're really trying. And also if you're not trying, this is happening all of the time. Okay, anyway, all right, so let's talk about fertilization. So here's this video. I'm going to play it once through so you can see what's happening. On the left-hand side, or on the right-hand side, you have I don't know what scanning microscope they've used, but you can actually watch the electrical change over the cell. So you can see that it starts from the top right-hand corner and makes a wave all the way down. The picture on the left-hand side is what's actually happening to the physical cell. And so as soon as fertilization occurs, then this kind of like envelope appears all of a sudden. And we're going to talk about those two here individually. So let's talk about the one on the right first. So what's showing on the right is called the fast block to polyspermy, which again is talked about in chapter 29-2. I don't even write it on the slide because we're not going to test you on it. It's called the fast block because it's all electrical and it happens immediately. It's a huge wave of calcium that gets spread across the membrane of the cell as soon as sperm pass through that membrane of the ovum. It's called fast block because it happens immediately. and it's a block to polyspermy, poly meaning many, spermy meaning sperm. So it's the first block to prevent multiple sperm from entering the egg. Because remember, this one egg is infiltrated with, I don't know, billions, trillions, a stupid amount of sperm, right? So that's on the right-hand side. On the left-hand side, at the same time, you finally see the second block to polyspermy, where the inside of the cell kind of changes shape a little bit, and then you have this expansion of this envelope, which I forget the name of the envelope off the top of my head now, but that also is preventing multiple sperm from binding and latching on and trying to enter into the ovum. So that's the slow block to polyspermy. Where's the actual sperm? I don't even see it in this video. Wow, that's a great notice. And actually in this video, if you watch in the bottom right-hand corner, on the left-hand side of the screen, you can oh wait, maybe it's the top left-hand corner. Uh-oh, I'm gonna have to watch it again. Oh no, top right-hand corner. Sorry, top right-hand corner is where the sperm enters. So you don't even see it. It's like such a small, minuscule piece of time. And we can also slow down this video. You can just Google fertilization video and it'll pop up on YouTube. But you can see where that entry point is what triggers the development of that envelope, and also what triggers that fast block on the right-hand side of the video. Okay, anyway, I think it's super cool. Eggs are awesome, and sperm are also really cool, and this whole process is really cool. So, okay, anyway. Okay, so the rest of this chapter talks about contraceptive methods, STIs, and development. So let's go ahead and talk about contraception first. Your book gives all of these examples, or most of these examples, I should say. I picked this picture from the CDC because I think it does the best job in summarizing what's going on. So in the bottom half of the page, or bottom third of the page, are the less effective methods of contraception. So if you are purposefully trying to prevent getting pregnant, the bottom third is the least effective method, and the top third is the most effective method. So let's go ahead and talk about the top third first. I'm going to start on the right-hand side. So IUD, intrauterine device. This is a really small T-shaped device that comes in a couple different flavors. Not like strawberry or raspberry, but like copper, no copper. And this is pushed past the cervix and sits in its little T shape just at the base of the uterus. It either contains copper, which prevents the release of, I forget which hormone specifically. I forget. But then the other one is releasing its own set of hormones to basically prolong the progesterone production of the corpus luteum. Then you have tubal occlusion. This is where the uterine tubes get tied. Vasectomy, this is where the ductus deferens get tied. And then implant. So this is something that in recent years has gotten a lot of controversy because women, probably just under a decade ago, that had the implant went through a lot of, or had a lot of psychological side effects. And it was very traumatic for a lot of folks. Luckily now the new ones that are on the market have not had any of these issues. And they're highly effective because it's a really small, it's done in the clinic. You don't have to be under, you don't need any massive anesthesia. They just put it right under your skin, usually at your arm, usually just superficial to your biceps, brachii. And this lasts about for 3 months, and it continuously is releasing hormones, again doing exactly the same thing as the IUD. None of these in the tier 1 are 100% effective. Nothing in biology is ever 100%, but they are really close. They're like in the 99%. Even the vasectomy and tubal occlusions, you can fertilize an egg outside of the female reproductive tract, which is, again, crazy to me, but that happens. And the sperm can also still find a way to travel, even though the ductus deferens gets severed too. So, just letting you know the numbers. Okay, tier 2. Let's go. We can go left to right. So injectable first. So this is a series of injections. I think it's once a month. Of, again, hormones. Pill, same thing, but daily. Usually it's 3 weeks of either estrogen or estrogen and progesterone combination pill. This is one of the most common ones in America that is taken, and there are many companies that have found ways to make this really affordable and or free for women. And then usually the last week is either a really small dose of that hormone or no dose at all. Then you have the patch and the ring. Patch, same thing as the injectable, except it's a wearable patch. And the hormone, which is a steroid, so lipid soluble, right, is just going to diffuse across the lipid bilayer and into the system and slowly trick the body into thinking that you're pregnant again. Ring, similar idea, except this is put at the base of the uterus and is again consistently secreting hormones. Ring needs to be replaced, I believe, every month as well. I'm not sure on the patch. Okay, least effective, absolutely least effective. So male condom, these break, they slip off, they're lied about. It's difficult to depending on what side of the coin you are on, convince other people to use it in the heat of the moment, etc., etc. They should never be used on top of one another, so using two at once or using a male with a female condom or a diaphragm, female condom. These also come in a variety of flavors, literally and figuratively, some of which can be ruined against certain types of lubricants, and some of which are more, if you have like an allergy to latex, they make some out of like sheep stomach, which is porous. So it's good at preventing pregnancies, but those ones are not good at preventing STIs. But condoms are one of the best ways to prevent STIs. Okay, fertility awareness-based methods. So this is what I was talking about with the temperature checking, or if you track your cycles for X amount of time, or for X amount of cycles prior to actually trying or not trying to get pregnant, you can actually kind of time when the ovulation period would be. Lots of good apps on the market to use this if you're interested. Just not necessarily surefire way, because what if you miss a day? What if you aren't paying attention one day? What if you wake up in the middle of, or what if you wake up the next day and you started menses, so you don't actually know what time you started menses at, etc., etc. Diaphragm. So diaphragm is similar to the ring in that it sits at the base of the uterus. It's a temporary method, so used during every vaginal intercourse. It can slip, it can move, sperm can still get around it. Sponge, same idea, exactly same location. Withdrawal method, this is where the idea of pulling out before fully ejaculating. However, pre-ejaculate has a lot of sperm in it as well, and typically some is released while already engaging in vaginal sex, so it's not a recommended method. Female condom is like the inverse of the male condom. These are very interestingly described in the female Bible book, or the vagina Bible book that I talked about at the beginning, so I highly recommend reading it. Essentially, this sits at the base of the cervix and wraps around the cylinder of the vagina, meant to protect against STIs as well, better at protecting against STIs than it is at preventing conception. Spermicides. Spermicides are injected into the urethra of the male, and the idea is to ruin the ability for the sperm to live in that environment before they exit. There are some methods being developed for more birth control methods for men, but none of those are yet on the market, and to my knowledge, I don't know how much they're being studied either. Okay. So again, pulled from the CDC, this beautiful four-step sequence of how to properly use a condom. If you are not already familiar with, or if you would like a refresher, or if you think you already know, please read this anyway. So I won't read through it, but it's there for you as a resource. Leading into STIs. Your book calls them STDs. That is the old terminology. Now they are called STIs. And this is a massive, I don't want to say it's a massive issue, but it's a huge public health issue that's on every public health specialist's mind. You get about 20 million cases new all this data is pulled from that CDC, by the way. This is just in the United States. 50% of those are average between 15 and 24, which makes typical sense. These are typically the most sexually active individuals, the most highly experimental individuals. Frontal lobe isn't quite fully developed yet, et cetera, et cetera. Some STIs can actually cause infertility, which can be really devastating depending on what your goals and plans are. Condoms can decrease the chances of obtaining any of these STIs, but definitely not by 100%. That means that you absolutely have to be using it in the right way, which is why I include the picture in the previous slide. I include links to the CDC and D2L if you're interested in more detailed info, if you're interested in per area, per region, per race, sex, whatever, all of that stuff. It's on the CDC, and the CDC has a lot of really good info on this. But fast facts, just from Colorado, just from the United States. Chlamydia has seen a real spike for whatever reason since 2014, and actually Colorado has specifically seen a larger spike in chlamydia compared to the other STIs, and then followed by gonorrhea, primary and secondary syphilis, and congenital syphilis. So congenital meaning in utero passing on to child versus primary and secondary. I'm not sure. I would assume primary would be sexual intercourse and secondary would be not sexual, but still exchanging of mucous membranes. The numbers are rising. It is important to pay attention to this. It can be really expensive to treat some of these things. It can be really uncomfortable, really difficult to have conversations with other sexual partners when you obtain one of these, but there are lots of resources for you if this does happen. I think the last stat that I read was at least 80% of people will actually obtain some STI in their lifetime, which is a massive amount. So it's super important to be familiar with not only the names, but the nicknames and the street names of each of these, which I'm not even really familiar with. I'm trying to practice learning those. But this is a huge public health thing, and they usually spike in different bubbles, different areas of the country. There are lots of really good private resources, lots of good clinics that will even help you have that conversation with other sexual partners in order to tell them that you tested positive for one of these. And for children in Colorado, I think the age is 14, but from the ages of 14 to 17, you do not need an adult to you do not need a parent's consent in order to be treated and tested for any of these STIs, which is really important. It helps prevent or it helps increase education for these teenagers, and it also helps prevent transmission as well. So every state has a different age cutoff. Some don't even have that age cutoff. They just say 18 and above, but that's what I know for Colorado. Okay, development. So if you're interested in this stuff, again, I would recommend taking a developmental biology course. Usually they'll talk about like frogs and mice and how they go through their developmental stages, but a lot of them are really analogous to humans. What I did was I took the highlights of what I think is important and I put it on this slide. So this is really all that you really need to take away from this subsection. So from fertilization, just terminology, from fertilization, then you have a zygote. That zygote then becomes an embryo at the end of 7 weeks, so just the beginning of 8 weeks. And then after those end of 7 weeks, beginning of 8 weeks, then you call it a fetus. And that is accepted across all clinics. On the right-hand side, you have a picture of what is happening at the gonads for that undeveloped fetus, or that developing fetus. And the top picture shows you both the male and the female reproductive tracts undifferentiated, and then what happens to them if they differentiate into male and what happens if they differentiate into female, and the terminology for each. So around week 7, male gonads develop. If there is no Y chromosome, then the female gonads develop a week later. With the help of testosterone, you will continue to produce male reproductive structures. So the vas deferens will form from the Wolvian ducts, and you'll keep testes. We call them gubernaculum testes. I believe I mentioned this in the male repro chapters. because they have not yet descended. And then towards the end of development, they will slowly start to descend, if not at the close to birth. For without testosterone, the female reproductive tract will remain, and the male reproductive tract will disintegrate. So the Mullerian ducts will continue to develop into the uterine tubes, and then you can see those gonads differentiate into ovaries. That's it. That's all that I want to mention about this one. Okay. Then this is a nice summary picture. I think it's just really interesting. It does a good job of making the structures analogous to one another and what develops from what. So at 6 weeks, you can see anterior, you have the genital tubercle, urethral opening, genital swelling, and then the anal fold, and then developing it depending on if there are more or less female or male type hormones, what ends up turning into what. So the genital tubercle turns into either the clitoris in females or the penis in males. The anus stays as is, and you can tell all of the complications in the middle. But what's important here is that this is not a black or white situation where it's either a penis or it is a clitoris. There are lots of people that actually experience somewhere in the middle. There's lots of variation in this area. I'm not sure if I can speak to the specifics of how we have that much variation there. I'm sure it's a hormonal and genetic thing. But there are folks who actually are intersex, who have both male and female reproductive parts, and both male and female external genitalia. This gets really complicated. There's a very wide spectrum of what's going on down here. So even though this picture splits it right down the middle, it is definitely not a black or white system. But I think it's really interesting because it does a good job of showing you the differentiation as time goes on. Okay, last but not least, aging and homeostasis. So aging, don't do it. It's terrible. Testosterone levels start to decrease, like I said. Your book says between 50 and 60, but I've actually seen studies that say 65 and up, so whatever. Older, menopause age starts to taper off. Menopause for women typically occurs between 45 and 55. There's something called perimenopause, so near menopause, showing symptoms of having menopause, but it's not quite yet menopause yet because you're still ovulating. Premature menopause, which sounds absolutely terrible to me, and knock on wood, I feel for these women, but this is where you are having menopause before the age of 45, and typically this lasts for a really long period of time, almost through like the actual menopause years. Menopause is typically like those hot flashes, changes in hormones, emotional swings, physical changes, difficulty producing enough estrogen, so maybe lubrication during sex is really difficult, etc., etc. But what's happening during menopause overall is ovulation is slowing down and or stopping or has stopped. And it's, of course, different for each female. For testosterone, when the levels are decreasing, spermatocyte production is lower, and then all the other sexual functions that come from being maintained by testosterone are decreased. And then, as always, the homeostasis picture that shows you how the reproductive system tags into all the other systems is always fair game for the exam. Other than that, I have nothing else for you all. This has been a pleasure teaching you. I wish you all the best of luck. This has been a lot of fun. Thank you all for making it through this online portion of the course. You all have been fantastic. If you have any questions at all about this chapter or any other chapters, today, tomorrow, 5 years from now, whatever, you have my contact information. Please, please, please don't hesitate to ask. I love learning with you, for you, and love having conversations about this stuff. So any and always, I'm always available. And as always, you have those practice questions at the end of the chapter if you're interested, but that's all from me.